Welcome back. This will be the last and final video on the infrared topic. Now, I could go on for days regarding more and more videos on the same topic or doing 2 million examples. That's not the point. I've given you the gist of what it is that you really need to know to be successful with the topic. Now, I don't consider myself no IR expert by any extent because I don't run IR samples on a daily basis. But you saw how little time it took for me. I didn't spend considerable amount of time on anything, maybe except the last one where there was a little bit of a close call, but we still had other markers that had easily won the game. But I made it maybe I looked a little slow because I wanted you to see that that C triple bond C can be wishy-washy. So that's what I was trying to point out. So it took a little more time, but we had already identified what the correct answer was based on the other molecule, right? So if you even understand what I've just told you in the previous video, you know more than enough to tackle a situation, right? Now with some practice in class, this may not even look hard because I don't expect you to memorize the table. And if you use the table literally and go approximate with the values provided to what's on the graph, you can decode this in a matter of seconds. So that's exactly what we're going to do in this video with 2 sets of graphs. And then I'm going to leave you with a practice, which you will practice and include it in. I'm going to have you actually turn in this as just an activity or whatnot. But so let's get started. So again, this is what we had done earlier. Okay, so here's the molecule. So I purposefully threw 2 extra ones just for fun, and I want you to tell me what this would be. Now, if you see this little tooth-like looking thing, right? It's not very strong, but you can still see the tooth, right? So we know we have a CH, right? Now, as I said, when you have a molecule like this, there is no CH. This is aromatic, benzene ring, right? It's all C double bond C altered. So there is no single bond in this molecule anywhere. So right away, this is even out of contention, right? Now, this is very unique. We've not seen a giant tooth in the middle of this. And this is looking interesting. We got 2 peaks. One all the way somewhere towards the 1000. That's massive. We've not seen anything this massive at the 1000 mark. And then we have not seen a giant looking tooth like thing in the middle of the graph either. So this is unique, right? Now, if you go to the graph and look at what are the peaks that are extremely strong, you see there are multiple peaks here. It's hanging off of this. This is 1, 2, 3, 4, 5. You see, this is multiple peaks, right? There is only one thing on there that's multiple. That is a COC stretch, right? This is a C. This is a C. It's a COC stretch. It says, what are the values? 1250 to 1050. Well, that seems to make sense. That's about 1250 to about, say, 1050, right around there. Again, we're making some assumptions. So this is just for a generic case, but we kind of know that this is somewhere in the ballpark. But the key giveaway is the several. Okay, that's an anhydride. Well, you're not convinced. Okay, that doesn't look too convincing to me. Well, if you go look at the anhydride, there's a C double bond O, right? You see they didn't put a range. They also gave a comma for 2 separate values. One is from about 1840 to 1800, and the other is about 1780 to 1740, these are the ranges that they're talking about for the 2 peaks. Because we have 2 C double bond OCs, we should technically expect 2, but because it's asymmetric stretching, you expect one to be on one side and the other to be on the other side, which is why it's showing up. So right away we know this is not it, because remember, if you had this is part of the acid, so we would have had this giant peak here, right? Remember that giant peak we saw like this? Like this? This is for a OH in an acid. The fact that's missing right away tells you that it is not an acid. And the fact you got a C bond H stretching indicates you cannot have a benzene ring unless I spoke too early. In this case, there is not, but say you have a bunch like this and then you have this, then maybe this could be the CH stretching. But then again, this fails on another count because this is still an acid. We should have still had this. So it fails on two counts because the fact you don't see it, an acid functional group, you could have straight away eliminated this and went for this. But I went a long way route just to justify the fact I gave this molecule in the first place. So our answer is, again, it took a lot less time. If I had just went for a quiz like thing, what is the answer? I would have done it in 30 seconds or less. But that's, you see the point how I'm going about approaching I'm using the table. All right, last and final quiz. Now here's what I was really interested in. What's difficult about this problem? Well, this has acid as well, right? In fact, I designed this and then went back and designed the previous one. You can see the resemblance of these two guys, right? In fact, I only had this and then I went back, found the spectrum, and then tried to reinforce this onto the previous one. And that slide became the first one. I moved it to a later slide. They both have acid. Well, I'm happy. I'm happy with this. This is acid. Still doesn't give away which one is which. Well, this is the C double bond O spectrum. As I said, this single sharp peak is C double bond O. Well, that's in both either. So this is acid. This is the OH in the acid. And this is the C double bond O, which is around 1700. This is around 3650, some like 3100, something like that, giant peak, okay? Or sorry, 2500, something like giant peak. What is really the giveaway again is the tooth. This tooth right here, it's there. It's being overlapped by this giant peak. It's like, you know, that you have big peaks in Yosemite, but then because there's so many other mountains in front, you can't see the actual peak that you see in all photographs from every angle because it's been overshadowed, right? So same thing, this has the CH peak, right? Because like I said, when you have a benzene ring, there's a higher chance of it having, unless like I said, I drew, if this molecule had been looking like this, then maybe, you know, maybe you can argue that there was not there. But what other way can we conclude? Well, there is a CH2 bend, right? Which is around 1480, which is this. There's a medium peak, right? This is a CH2 bend. Well, there is no CH2 at all. This has a bunch of CH2s. This is no CH2s. CH2 bend is 1480 to 1440. There's also a CH3 between 1390 and around 1365. You see those two peaks, which are these. This corresponds to CH3. Again, there is no CH3 at all in here. So all that suggests us that this is our, what about this? This medium looking size peak, medium to weak. You don't have those intermediate categories, just treat it as medium. Where is that at? It's about 9, almost 1,000, right? What would be 1,000? That's anything remotely related to, well, there's not that many that is 9, that's in the 1,000. But I would say that it's probably the CO, some way of, there's no COC, but I don't even know what this peak is coming from. Based on the table that we have, I can't nail it down. That's hard. That's a good one. That's really, really hard. I don't think there isn't enough information here to identify what this peak could be, at least based on the table of information. But we have enough evidence to suggest this is not the case. This is the case. and that's it. So I'm going to leave you with 4 spectrums and 4 molecules. Your job is to identify which one is which using just the table. Like I said, use the left-hand side of each graph. It has more valuable information than to the far right side, and you will turn this as a activity in class, right? So that's it. We're done with infrared. Stay tuned.